Hello, everybody. Good, the timer is not started, so I can waste a little bit more time. The slide deck, maybe I add a little bit of side information. Jeff Cross helped me to create that, and in these slides, you will see pictures of his beautiful pigs. And I have to say that because he paid me for it. I'm very thankful that he helped me. Even if it is not true. No, it is true. Okay, whatever. Let's start. A couple of years ago, Angular shipped features that are called, or switched the rendering engine. Now we have IB enabled. We dropped the old engine, and we have now new possibilities. And as all the development took quite some time, the RX Angular team had time to write a small library to help with all the new cool features. What are we able to do now with this new setup, or what are the hyped topics here? People speak about component state management, per component change detection or local change detection. We talk about non-blocking rendering, fine-grained reactivity, and one of the last and most exciting topics here is fully zoneless applications, or applications where zone is optional. This is on the roadmap of the team, and guess what? It is already available, and I will show you a lot of demos how you can use it already today. I will introduce you to a library that I created a couple of years ago. It's called RX Angular, and it focuses on performance and developer experience. And the first part is performance, and today we will also mostly focus on the performance part. And Bootstrap performance and runtime performance are completely different topics. If you are in the topic of performance, you maybe realized that even if both of them are hard, runtime performance is harder to reach. So I picked runtime performance. Maybe I can show you some cool tricks. If we speak about performance, we should know what a frame drop is. And here I show on a picture some tasks that visualize how, let's say, tasks that produce bad user experience look like. They are marked with these red boxes, and this is what we try to get rid of in general if we talk about performance. A lot of those long tasks are created because Zone is running the change detection for Angular. And here you see a comparison of a pretty big application. And in this big application, we on the upper part, render the whole application and interact with the whole application as Angular would tell us, so natively. And in the lower part, you see the same application that we refactored with RX Angular. And as you can see, it is way more faster. Have a look at the yellow colors, they are less. Have a look at how little frame drops we have there. And this is already possible today. But there is a problem. If you start with an application, and it is a small pet project, you can easily exclude Zone from the beginning. You can rewrite your application, and it should not be a big problem. If you have production apps that you could also write from scratch, it would also work somehow, but believe me, bigger existing applications, you will not get zoneless. It is a lot of work. You have third parties, you have edge cases that you don't even know, and it will only burn money and time. And this is what we realized a couple of years ago, so we started to focus to solve all those problems in a very efficient way, and this is basically all about the RX Angular implementations that focus on the Zone part. My name is Michael. I guess I don't need a big introduction. I just want to mention that I'm interested in performance, and I run a company that is also doing the same thing, focusing on performance, architecture, and of course Angular. I hope I can help you today to understand some of those problems and fix it. And I guess one of the things that we should start with is what we need. What do we need to implement all those cool things? Rx Angular is one of the things we need, but also we need knowledge of concepts. We need to understand change detection and state management, and I want to start with change detection because I guess it is one of the least known topics. It is very complicated. If you really dig in, there are a lot of things that you need to understand, and here I just quickly want to pitch the three sections: component tree, dirty marking, and rendering to you, that we have a concept of how is it working at the moment and what do we want to get rid of. So we have a component tree. This is a tree structure. At the very top, there is a service that's called application reference, and this application reference holds a reference to your most upper component. If we look at a real website, all those red boxes here are components. This is a visualized, pixelated form of our component tree. We could also think about a component tree in this way, a real tree structure that has parents and childs. And within that tree structure, we need to apply updates. And those updates at some point need to get visualized because we as a user want to see it. How is this working? So we have a process that is called dirty marking. In short, a lot of things, but also all the event listeners are patched by zone. So if a user clicks a button in a specific component, due to that patched event listener, we realize that there happened a click, and then we mark the path from our very component to the top, to the very top, dirty. We set a flag on that component and we say, this is the path from where I introduced the change up to the highest component, to the app component. After that, zone realizes that something happens. Our reconciliation process is started with this, and zone calls a method on our application reference that is called tick. And this tick method renders the whole tree from top to bottom. And in this picture, you see an application that has change detection on push enabled, so we only render the path that is here marked with these red triangles. It's already a performance improvement, but of course too little to have proper runtime performance also in bigger applications. So this is a bottom-up, top-down rendering approach. Due to zone, it is also a pull-based approach, and this is what we want to get rid of, or this is what we got rid of in the last couple of years where we worked on Rx Angular. A little bit more info on zone. If you compare Angular with any other framework, it's obviously completely different. Mostly any other framework has explicit change detection. Angular has implicit, magical change detection. Here you see how browser APIs are patched, but I guess we don't need to discuss all those things in detail because I only have 9 minutes left and I need to get to some demos. One of the first demos is that I want to show you how confusing it could be to have change detection running. And I have here buttons, application of tick, mark for check, whatever. And if I click that button, you see numbers counting up and down. Maybe I zoom in a little bit. So you see that those numbers are counting up and down. And as you would expect, if I click here, this component and this component are not updated because there is on push. If I click here, I have the dirty path. You see, even if I have on push enabled, it will get re-rendered. And this is basically a default setup. It really gets confusing if you work with projected views. If I do the same interaction here, for some reason, this component is updated and the other one not. So you see, it's not really easy to understand all the edge cases. And here I see that I'm signed out. And I hope that it will just reload. Yes, okay. Perfect. So change detection is non-trivial. With those changes in the numbers you saw, it is maybe even confusing for us to understand why a component gets re-rendered and why not. This is what we want to change, and to change that we need two components. We need state management and we need template rendering. For state management, we basically use that to transition from an implicit change detection model to an explicit change detection model. We explicitly change our state, and this is basically done in two layers. We have a reactive approach and an imperative approach, and this state management tool that we shipped should fix both approaches in a very clean way. I can show you quickly how we use that API and where we can save boilerplate. I open up a random component and I just start to type. And if I would implement, and in this case I quickly extend it so that I don't need to wait. And if we implement something, movies is an empty array of an object, okay, we could connect different observables to that state. So we have a set and a get method. Set and get are basically imperative methods, and I guess I don't need to demo how we can set or get specific properties. This is how I would set and get it. But when it comes to observables, it's not so trivial. Normally, you need subscription handling and so on and so forth. To receive values, you also need to add some operators. And this is what we solved with the two APIs that are called select and get and connect. And select and connect is basically the slimmest, quickest, and most on-spot thing how you can run change detection on component level. Here, I select the property movies, and in the second line here, I could also connect me a property movie and assign all changes of an observable directly to it with that single line here. It's not only one-liner, it's a short one-liner. So this is how we did change detection, and we need that to have explicitly introducing changes to our application. The other part that we also did is template rendering, and with the template rendering, we basically introduced a lot of fancy things. First of all, we implemented in a way that you can switch from default Angular's change detection to our change detection with just a configuration, so you will always know if changes and bugs are introduced by that specific library or in your app, or they were already existing in your app. And therefore, you can switch to native change detection or to our different strategies. What we did now is we re-architectured how this top-down rendering approach that Angular does normally and looks like this is running. Everything here that is yellow is unnecessary over-rendered, unnecessary re-evaluated, and only the green square that wraps the H letter here is necessary. And within 2 steps, we switched to local component level change detection, and you see there is only a little bit yellow now, and with our structural directive, we managed to only update one specific DOM snippet and nothing else. This is real fine-grained reactivity. So, if we compare that approach, the right side has a lot of green things, the left side has little green things, and green here is the amount of render work that we do. So this is already, I guess, a really nice improvement. I can show you quickly, even if I have only 3 minutes left, a couple of demos how those things are used in the template, and therefore I just open up this component here, and I can show you that you can use the RxLet directive in a way where you pass the observable, you define a variable that should update whenever the observable emits a new value, and then you can access that variable, and this variable is bound to the specific DOM snippet. We also have other things. This is basically replacing the ngIf. We also have other structural directives. We have an rx4, an rxif. We have also things that can unpatch event listeners to really get fully zoneless applications, and you can use them as normal structural directives. If you do that, your application will already be a little bit faster and less code. But the most fanciest thing that you can do is chunked rendering. So by using the directive, getting rid of all async pipes, you are already partially zoneless, because those directives run completely outside of zone. They have push-based change detection, not pull-based as with zone.js, and they run their work already on component level. In a second step, we basically introduced a technique that we can even, on this component level, get rid of all the long blocking tasks. And Angular natively has no notion of the frame budget in the rendering cycle. That means Angular schedules a lot of work, blue boxes here, and it has no awareness of how much time passed already, and how much time is left to have still good user experience. Still no frame drops. What we did is we basically implemented a way where we can realize how much time is left, and if the time is over, if enough work is processed that I get close to the 50 milliseconds, we just say stop to work off that queue and schedule it in the next task. And this is what you see at the bottom. You have a lot of blocks that are always the same size. They will never be longer than 50 milliseconds, and this is the way how we introduce chunked rendering, that is basically never producing a long task. We did measurements, and instead of demos, I show you measures, right? This is a ngFor. This is rendering two nested lists, and in this list, I visualized it as a table here. I have only one value that is either true or false. This one value shows either a red cross or a green check mark. And by just initializing that, clicking it 4 times, or starting an interval and running updates very quickly, we see how much work is needed to do that. This is a normal application. It runs on zone. You even, if you read a lot of flame charts, you can see here already the upper part. This is basically zone related, and you see that every single interaction caused a frame drop. This is a close-up of the list, so you see under full load, any single update produces frame drops, a lot of yellow and a lot of those red bars, a lot of frame drops basically. What we did is we switched to zone-less change detection, and we chunked up the work. So if you look at a comparison of the old table and the new table, you see on the left side you have one long task with a lot of overtime, the red area here, and this is bad user experience. This is what we don't like. This is when the screen freezes, you try to click, you hammer that button, nothing, no feedback. On the other hand, you see the concurrent way of rendering change detection, and here you have a lot of small tasks, and in between every task, the browser or the user can click, can interact, and you never have these bad frozen UIs, these blocking UIs. The implementation is pretty simple. Let me quickly jump back. You just put an Rx instead of ng. That's it. You don't even need to use an observable here. Cool. What is the output? This is the output. We basically have not a single frame drop, any single click, any single update. Even the high load efforts here are extremely efficient. It's not only less frame drops, but the work that is executed here, if you look at the yellow color, is less than a third. An extremely good boost by just changing 2 characters in your application. This is what you can get if you exclude a part of your application from zones change detection. In this case, we just excluded the table here. That's I guess, pretty good demo, and as the time is over, I will not show the navigation demo. I will also not show you how to take an application fully zoneless. The last thing that I want to mention is that if you have zones still included, you even see that in the timing marks and the bootstrap phase and the bundle size and everything. But there is no time that I can put everything zoneless now because the time is over. So I have to say goodbye. Thanks for your time. And maybe next time I will speed up and can show more demos. But that's it. That was partially zoneless. Thanks.